Alrighty, hello and welcome back to Mr. Pog Talks About Math and Stuff. So today we're going to talk about multi-step equations, right? So, we've talked about two-step equations and inequalities so far. We're going to take a look today at what happens when you've got quite a few more steps sometimes in those. Alright, so they might sound difficult, right? They might have variables on both sides, distribution and or fractions, but we're going to break it down step by step. So these are our steps, right? If you need to pause here and write them down, that's fine. I'm going to kind of run through them. Our first step is that we are going to find a common denominator and multiply all the way through our equation, right? That means both sides. Off to the side of here, I'm going to write out little notes, just like a little reminder, like, all right, if I have fractions, that's when I need to find a common denominator, right? If you don't have any fractions, you don't need to worry about it, which is pretty nice. After that, we're going to distribute to clear any parentheses that are hanging out, right? So distribution is something we've covered already. Be sure to check back on that if you need a refresher. After that, we are going to combine any like terms that we have, right? So that means that we are going to be adding and subtracting things that, match up. They need to have the exact same variables and exponents on those variables, right? So if I have x to the third y squared, I could add on 3 more x to the third y squareds, right? After that, I need to get all of my variable terms to one side of the equal sign, right? And the way we're going to do that is either by adding or subtracting to move them around, right? Then we're going to move around the constants, right? We're going to get all of our constants to the other side of the equal sign, again, by adding or subtracting, right? It's really important that your variables end up on one side, your constants end up on the other, right? Because this last step, we are either going to multiply or divide to clear the coefficient of the variable, right? So our coefficient, right, remember, is the number that's in front of a variable, so it's like 5x, right, which really does mean 5 times x is going on there, right? So we're going to clear that coefficient, and then we're good. Right, let's take a look at a couple examples together. So for this first one, we've got 16x minus 5 equals 10x plus 19, right? So first things first, I want to move all of my variables over to one side. And actually, let me rewind a little bit. Let's think through our entire process of steps right up above there. So, common denominator. I don't have any fractions, so I don't need to do that step. All right, after that, distribution. All right, I don't have any parentheses to distribute into, so I don't need to do that either. Combining like terms. So you might be thinking like, well, let's take a look. 16x and 10x would be like terms. And you'd be right, except here we can't combine them because they're on opposite sides of the equal sign, right? We can move things around the equal sign, but that's where we have to do the inverse operation to move them around. So that's not what we're going to be doing on that step. What we are going to be doing right after that is we're going to move all of our variable terms to one side of the equal sign. Right, so in this case, that means that I'm going to, choose either 16x or 10x and move them all to one place. I'm going to choose the 10x, right? So this is a positive 10x, right? There's no negative in front of it. So to get rid of it from that side, I'm going to subtract 10x over there. And I got to keep everything even, so I'm going to do it over on the left as well. Okay, so 16x minus 10x over on the left is going to leave us with 6x. Right? That minus 5 comes along. Those x's are gone. And all we're left with on the right side is 19. Okay, after that, what we got to do is we need to move that negative 5 away from where the variables are, right? We want all our constants on the other side. So what I'm going to do is I'm going to add 5. Right? Adding 5 is going to move that on over. It'll be gone from over there, so we'll have 6x left over. On the other side, it'll be 24. Okay. After that, easy peasy. 6x is 6 times x. I don't like the sound of that. Let's divide to get rid of that. So if we divide both sides by 6, we're going to get that x is just 4. All right, and then we're good to go. That's really all we're doing. Okay. What I'd like you to do, if you're feeling up to it, pause here and try out number 2, then unpause when you think you got it and you can check your work. If you're feeling a little shaky, follow along with me. So first things first, right? I'm thinking through that whole process. I don't have any fractions, so I can skip common denominator. I don't have any parentheses, so I can skip distribution. I don't have any like terms on the same side, so I can skip combining like terms. I'm already on to moving around my variables here. So what I'm going to do is I'm going to move, let's say that 11x over to the left. Right? I know a lot of people like their x's to be on the left side of the equation, so let's do that. So again, I'm going to subtract 11x, right? I want it to cancel out from over there. I got to keep everything even, so I'm going to do the same thing on the left. Right, 21x minus 11x leaves us with 10 of those, 10 x's. Minus 9. The 11x's are gone, and we have minus 39 left over. Okay, after that, all my variables are on the left. I need to move all my constants over to the right, which means I'm going to add 9 to move that on over. All right, so now we've got 10x equals negative 39 plus 9 is going to bring us up to negative 30. And if you're feeling a little shaky on negatives, remember you can always use a calculator. No shame. After that, 10x is 10 times x. And again, we're going to undo that times 10. So I'm going to divide by 10 on both sides. All right, when I do that, negative 30 divided by 10, it leaves us with negative 3. And then we're good. That's it. All right, if you did that one right, give yourself a pat on the back. We're going to move into some that have a little bit more to them, but that is definitely a good start. Oh boy, this one looks a little gross. And right off the bat, it's going to be a little tricky. We'll talk about that in just a sec. So again, I'm thinking through my process on this one. I don't have any fractions, so I can skip common denominator. I do have parentheses that I need to distribute into. All right, so the first set of parentheses over on the left side, right? Be careful. Don't distribute the 7 in there, right? Don't go like that. That's not right. We need to distribute just what's directly in front of the parentheses, which in this case is this negative sign. You'd be thinking like, oh, well, then what do I multiply by? So whenever you have a negative sign, you could also think about a little invisible 1 hanging out there. All right, so that's what we're going to multiply into there. Over on the other side, we'll set that up as well. We're going to be doing 4 into those parentheses just like that. Okay, so over in the red, right, we got 7 over there hanging out. Negative 1 times x is negative 1x. You could leave the 1 in there. You could just write it as minus x. Either one is fine. And then negative 1 times negative 5 is positive 5, so I'll have a plus sign there. Over on the right side, 4 times x is 4x. 4 times 13 is going to give us 52. Right, so we just did our distribution. Now our next step is to combine any like terms. Right, so I'm noticing over on the left side we have a 7 and a 5, and those sure seem like terms to me. So what we're going to do is we're going to smush those together. All right, so 7 plus 5 is 12. All right, after that, we're going to bring that minus x down, and then 4x plus 52 on the other side. Okay, after that, what we're going to be doing is we're going to move all our variables to one side, right? That's the next step in the process. We did have to distribute, and we had to combine like terms. We're on to that one now. All right, so now it just becomes like the last 2 examples we did. So I'm going to move this x over to the other side. I'm going to add x to both sides. All right, so we have 12 equals 5x plus 52. Okay. So all my variables are over on the right-hand side. I'm going to move all of my constants, meaning that 52, away from them, over to the left. All right, so that's why I'm going to subtract 52 from both sides here. We'll end up with negative 40 over there, 5x on the right side. Okay. After that, again, we need to get rid of that coefficient. That's 5 times x. So we're going to undo it by dividing by 5 on both sides. So at the end of the day, negative 8 is equal to x. Right. Cool. Easy peasy. Right. You might already know what I'm going to say. Try this one out on your own, right? Pause here, give it a shot, see how it goes, and then unpause when you think you got it. So hopefully you did that. I'm going to run through it, right? Pretty similar to the last one. I have this negative 1 that I'm going to distribute over on the left side. I have a negative 3 I'm going to distribute over on the right. So this will be negative 13 there. Negative 1 times x is just negative 1x, or minus x I'm going to write there. Negative 1 times negative 2 is plus 2. Over on the other side, negative 3 times x is negative 3x. Negative 3 times another negative 3 is negative, or a positive 9 rather. All right, cool. All set with distribution. We have some like terms to combine, similar to the last one. All right, so we're going to smush those together. Negative 13 plus 2 is going to bring us to negative 11. We've got that minus x coming along for the ride. And then negative 3x plus 9 over on the right. Okay. after that, still got to get all my variables to one place, right? Let's add x, just pretty similar to what we did on the last one. Okay, so we'll have negative 11. We'll get minus 2x plus 9 over there, right? So this might be where my steps got a little bit different than yours if you tried this one on your own, which hopefully you did, right? What we're going to find is that hopefully we should end up with the same answer, right? You don't have to do it the exact same way I do. I could have moved that minus 3x, right? I could have moved that over to the other side, right? So either way, we should end up with the same answer, hopefully, if we did it right. So all my variables are over on the right. I'm going to move all my constants, meaning that negative 9, over to the left. So negative 11 minus another 9 is negative 20. We have minus 2x on the other side. Last but not least, we'll divide everything by negative 2 to ditch that coefficient. And we'll get positive 10 is equal to x. There we go. All right, so hopefully it doesn't seem super duper bad. We are going to talk about some word problems though. So first one's about dogs. Dogs are fun. A dog breeder raises two kinds of dogs. The average Labrador puppy weighs 14.8 ounces and gains 0.5 ounces per week. The average Golden Retriever puppy weighs 11.6 ounces and gains 0.9 ounces per week. We want to figure out after how many weeks will the puppies weigh the same amount. All right, so my strategy for word problems, right, is to read it once through and then read through it again and kind of, keep track of important information either by underlining it or highlighting it, whatever you got. So we're going to read it through it one more time. Dog breeder raises two kinds of dogs. The average Labrador puppy weighs 14.8 ounces and gains 0.5 ounces per week. All right. The average Golden Retriever puppy weighs 11.6 ounces and is gaining 0.9 ounces per week. All right. So you might notice that I've highlighted these in two different colors, right? That's because they're talking about two different categories of information, right? We got the Labrador and we got the Golden Retriever. They each have numbers that kind of go with them. And then there's one last real important piece, right? We're trying to figure out how many weeks until they weigh the same amount, right? So how many weeks? That's what we don't know. That's what we want to find out. So the way that we talk about a number we don't know and want to find out is we use a variable, right? So in this case, what that means is that I'm going to use W. I'm going to call that the number of weeks. All right, you could use X, you could use Y. I would not suggest using the letter O, right? Because it'll look like a 0, right? But we're just setting up a variable so we can talk about that number of weeks before we actually know what it is. All right, so now we got to do is we got to set up an actual equation. So what I would suggest doing is I'm going to split it into two categories, right? On one side I'm going to have the lab, and on the other side I'm going to have the Golden Retriever. All right, we want to figure out when they weigh the same amount. So if they're going to be the same, should have an equal sign, right? Equal weights. For the lab, right, it weighed 14.8 ounces and gains 0.5 ounces per week. All right, so it started at 14.8. And then it's gaining weight, right? So we're going to add that weight on 0.5 ounces. All right, so something you might remember from the last time we talked through some word problems is the word per, right? So 0.5 ounces per week in there. That word per is telling us that we have a rate of change, right? And when we have a rate that's changing, right, we need to be able to account for all the different possibilities of it. So, the way that I have it written right there right now, 14.8 plus 0.5, talks about all right, that if we add those together, that'll account for 1 week. If I wanted to then account for another week, I would have to add on plus 0.5, and a third week plus 0.5, and a fourth week plus 0.5. Gets to be kind of a pain, right? We don't really want to have to keep doing that. So instead what we can do is we can multiply it by our variable, right? The number of weeks. That'll accomplish the same thing and account for all the different types of situations we might have, right? I don't know how many weeks it's going to be. We're going to do the same thing with the Golden Retriever information on the other side, right? It started with 11.6. It's gaining 0.9 ounces per week. All right, let's make everything nice and color-coded just like the other side. So this does not look pretty, right? I know that the decimals are kind of gross, right? But what we've got here is this isn't a multi-step equation set up and ready to go. So first things first, I'm going to move all my variables over to one side. I'm going to subtract 0.5 w's from over there so that I can move them over to the right. All right. So we're going to have 14.8 over there. We got an equal sign with 11.6. And then 0.9 w's minus 0.5 w's is going to give us 0.4 w's. Okay. After that, all my variables are on the right side. I need to move all of my constants over to the left, meaning that 11.6 has got to go. Okay, so 14.8 minus 11.6 gives us 3.2. And then 0.4 w is left on that right side. After this, we got to get rid of that 0.4. All right, and again, no shame in a calculator. We're going to calculate this out. 3.2 divided by 0.4. It's going to give us 8. All right, so 8 is equal to w. Right, so when we're working on a word problem, right, we figured out what it was, but we should put a unit on there, right? We know that w is the number of weeks. So our answer is 8, so we're going to say 8 weeks. Right, just put that unit on there. That's our answer. So after 8 weeks, we're going to have 2 puppies that weigh the same amount. Isn't that going to be cute? All right. So example 6 here, another word problem. We've got the length and width of a rectangle are x plus 4 and x minus 3 respectively. The lengths of 3 sides of a triangle are x, x, and x plus 6. We want to figure out what value of x is going to make the parameters of those equal to each other. All right, so what I might suggest, whenever you've got a problem and it's giving you, like, oh, we're talking about a rectangle and a triangle, draw yourself a diagram, right? It's going to make things a little bit easier to think through. All right, so I'm going to draw myself a rectangle. Oh my gosh, look at that perfect rectangle first try. And I'm going to label it, right? The length and width are x plus 4. Oops, let's undo that. They're x plus 4 and x minus 3 respectively. Right? I'm going to clue you in a little secret for what we're doing in math. It doesn't really matter which one you call which. Right? Being a rectangle, I know that that other side is also going to be x plus 4. This other side over here is also going to be x minus 3. Right? As for the triangle, right, it's got side lengths of x, x, and x plus 6. Right, so we're going to have something maybe like that. We'll label these sides as x, x, and x plus 6. All right. So what we're trying to do here is we're trying to figure out what value of x will make the parameters the same. All right, so if you don't remember perimeter is just what happens when you add up all the sides of a shape, right? You're trying to figure out how far around it is to go around the shape. So let's worry about the rectangle first. Figure out the perimeter of the rectangle. I like to start at the top of the shape and then kind of go my way around clockwise. So I'm going to start and say, all right, x plus 4, that's a side. I'm going to add on the next side, plus x minus 3. Cool, that's 2 sides done. Let's add on some more. Plus x plus 4, and then plus another x minus 3. All right, so that's all 4 sides of our rectangle taken care of. All right, I know it looks gross. Maybe you need to bear with me for a little bit longer. All right, on the other side, we're going to figure out the parameter of the triangle, right? So this one's going to be a little bit shorter, right? It's only got 3 sides. It's x, which is a side all by itself, plus another x, and then plus that bottom side, x plus 6. All right. When you're doing these on your own, you don't need to put these little like brackets I'm putting underneath them. That's just to kind of show like, all right, I have 4 sides of the rectangle all added, 3 sides of the triangle added together. All right, so might not look like it, but this is a multi-step equation pretty similar to what we've been doing. All right, so we got to think. I don't have any fractions, so I don't need a common denominator. I don't have any parentheses, so I don't need to distribute. But boy, howdy, do we have some like terms to combine. All right, so I've got x's over here, right? Look at all of them, right? And I've also got some regular old numbers over here that can also combine together, right? So on the left side, we've got a lot of things to combine. Over on the right, we also have some x's over there that can smush together, right? So lots of combining like terms to do. Let's start with the x's that are in the yellow, right, over on the left side. If I just count them up, x plus plus x plus x means that I have 4 of those. I'm going to have 4x from that. All right. So 4x from the stuff in the yellow. From the stuff in the green, right? A couple different ways you could do it. I sometimes like to do it in my head, right? Just say like, all right, I'm starting with 4 over here, and then I'm subtracting 3, which brings me down to 1, and then I'm adding 4 to bring me up to 5, and I'm subtracting 3 to bring me down to 2. But if you're not about that life, that's no problem, right? 4 minus 3 plus 4 minus 3 gives us 2 anyway. All right, so either way, the fact is it's a positive 2, so you gotta be a little careful about that. All right, make sure you have the right sign on it. And then on the other side of the equal sign, all we gotta do is smush those x's together. All right, so 1, 2, 3 of those gives me 3x for that stuff in the blue. And then that lonely plus 6 on the end. Didn't have anybody to combine with on the right side. All right, this looks much better. After that, we just move our x's all to one place. I'm going to subtract those 3 x's over to the left. We're going to get x plus 2 over there equals 6. And then we got to move that 2 away from where the x is. All right, so I'm going to subtract 2. And then x equals 4. Okay. So on this one, they don't really give us a unit, right? We don't know if we're talking about centimeters, inches, miles, light years, I don't know, right? But, it doesn't give us a unit, so we're fine to just leave it as x equals 4. Right? So hopefully that doesn't seem so bad. So you might notice that so far we haven't used that first step about the common denominator yet. Let's talk about a common denominator before we jump into the fraction ones. So fractions are a little spooky, right? Lots of people don't like fractions, but they're just division, right? They got a little special rules to them, but it's not so bad. So to find a common denominator, right, you may have heard about these in the past. What we really want to do is we want to find a common multiple that works for each fraction. So there are a lot of different ways to do this, right? One of the easy ways sometimes is to just take your different denominators and multiply them, right? So on a problem like this, if I wanted to figure out a common denominator for 2/3 plus 3/5, just do 3 times 5 and I would get 15. Right? 15 is a good common denominator, right? We could use that just fine. But I kind of like a different way sometimes, right? Sometimes our problems are going to have more than just 2 different denominators, right? And actually the second example we're going to take a look at has 3 different denominators. So an alternative way that you can do it, right? We're going to do it on this one just to kind of show it, is to make yourself a little table, right? We've got a side for 3 and I've got a side for 5. And what I'm going to do is I'm just going to list out multiples of each number, right? So 3, 6, 9, 12, 15, 18, 21, and so on, right? I'm going to do the same thing for 5. 5, 10, 15, 20, 25, 30, and so on. So what we're going to do here is we are trying to figure out the lowest number that these have in common as a multiple. Right? And in this case, it does still end up being 15, right? There's nothing wrong with that. I could also use 30, right? 30 is a common multiple of 3 and 5, right? So what we're focused on for the most part for us is we are just finding this common multiple, and then that's going to help us solve our equations, right? We're going to get into how it's going to do that in a little bit. I just want to practice with the common denominator first. Over on this other example, this is why I like doing it this way. Right? If I have denominators of 6, 2, and 8, sure, I could multiply them together. 6 times 2 is 12. 12 times 8 is what, 108? Or is that 96? Let's figure it out. 6 times 2 times 8. Gross, 96. I don't really want to work with that if I can help it. So let's try this other way out. 6, 2, 8. Make ourselves a little table. I'm going to list out some common multiples. Right? 6, 12, 18, 24, 30, 36, right? 2, 4, 6, 8, 10, right? One suggestion I have is if you have a small number like 2 and you're going to be writing a lot of multiples, try and go with the bigger numbers first, right? So I'm not going to go too much farther with 2. Let's pause for a second and let's do the 8s. 8, 16, 24, 32, 40, and so on. So the reason that I'm pausing on the 2s is because I'm just going to take a look and see, all right, is there something that 6 and 8 have in common? And as I'm looking, they do seem to have 24 in common. All right, so 24, I would also be able to get to if I kept doing the 2's, right? 12, 14, 16, 18, 20, 22, 24, right? So I would get there eventually, right? But sometimes if you do the bigger numbers first, you can kind of see what they should have in common. And then if you do a little bit of mental math instead of having to write out all those multiples of 2 and say like, oh yeah, 24 will work, right? Much better than 96, right? So what we're going to do here is we're going to take a look at some problems that have fractions in them, right? We're going to talk through one thing at a time. So the first step is to find a common denominator and multiply it throughout the whole equation, right? So in this one, our denominators are 2 and 5, right? So again, you could do the easy thing. You could just multiply them together, right? 2 times 5 is going to give us 10, right? If you wanted to do it out with a little table, right, same thing will work, right? 2, 4, 6, 8, 10, 12, and so on. 5, 10, 15, 20, and so on. 10 is the lowest number that would work, right? Again, you could use 20. You could use 500, right? That'll work too, but we don't really want to if we can help it. So 10 is going to be our common denominator. I'm going to multiply everything by 10. So I'm going to put everything in some big parentheses, big 10 on the outside, and we're going to distribute that into these parentheses, right, across the entire thing, including the other side. Okay. So when I do that, right, we get 10 times 1/2. All right. So there's a couple different ways you can multiply when there's fractions involved. Right. One way that I've seen people do it is they like to do like, oh yeah, 10 over 1 times 1 over 2. You can multiply straight across, right? 10 times 1 on the top is 10. 1 times 2 on the bottom is 2. And 10 divided by 2 is 5. That works perfectly fine. There's nothing wrong with doing it that way. Right? So if you feel real comfortable with that, go for it. Right? There's a slight like shortcut-ish kind of way that I like to do it. Right? So what I like to do is I like to take our common denominator on the outside, right? So I'm talking about this 10 over here. What I like to do is I like to take it and I'm going to divide it by what's on the bottom. Right? So 10 divided by 2 is going to leave us with 5. Right? So now I'm working with 5. What I want to do is I want to take that 5 and multiply it by whatever's on the top of the fraction. Right? So 5 times 1 is still going to be 5. Right? I know that might be a little confusing. Right? We're going to go through it on the other fraction as well. Right? That 5 does have an x that we don't want to forget about. Pop a plus sign down. Let's talk about the second bit. 10 times 1/5. So again, I'm going to take that 10, what I'm multiplying by, I'm going to divide it by what's on the bottom of the fraction. So 10 divided by 5 is going to leave me with 2. Right? I'm going to take that 2 and I'm going to multiply it by what's on top, which is just 1. Right? So 2 times 1 is just going to give me 2. Right? Over on the other side, 10 times 7 is going to give me 70. Right? So I will say that if that way of me multiplying fractions there doesn't work for you, if you're not quite sure about it, use whatever way you're comfortable with, right? Or you can ask me during class and we can talk about it a little bit more, right? Either way will work. So from here, this is just a 2-step equation, easy peasy, right? What I'm going to do from here is I'm going to move my constants away from where my variables are, right? Which means moving that 2 on over. We're going to get that 5x equals 68. And oh man, this is not going to come out too pretty, but that's okay. All right, so 68 is going to get divided by 5. We're going to get 13.6. All right, so divide everything by 5 on each side. And x will equal 13.6 or 13 3/5 if you want to write it that way. Either way, it comes out to be the same. All right, let's try another one with fractions. And actually, if you're feeling really up to it, right, give this one a shot on your own. Pause here, see what you get for a common denominator, multiply it through, see how it goes. If you're feeling a little shaky, stick with me. All right, so again, we're going to find our common denominator between 4 and 3. And again, you can just multiply them. You can figure out that it's 12 this way. But again, sometimes it might not give you the smallest one. All right, so I'm still going to do this out over here. 4, 8, 12, 16, and so on. 3, 6, 9, 12, and then I'm not going to go any further because we found that 12 works. All right, so 12 is our common denominator there. So again, big parentheses, 12 on the outside. right? If you did this one on your own and you used 24 or 48 or 36, right? Those all work as well. So this 12 is going to distribute into each and every part on the inside. Okay. So again, what I'm going to do is I'm going to take this 12 and I'm going to divide it by what's on the bottom of the fraction. So 12 divided by 4 gives me 3. And then I'm going to take that 3 and multiply by what's on the top of the fraction, right? So 3 times 1 is just 3. So we're going to get 3x there. Actually, let's adjust to that. Okay. Same thing over here, right? We're going to take this 12. We're going to divide it by what's on the bottom of the fraction. 12 divided by 3 is going to leave me with 4. So I'm going to take this 4 and I'm going to multiply it by what's on the top of the fraction. So 4 times 2 is going to give me 8. All right. After that, 12 times 9, just easy peasy multiplication. It's going to give us 108. All right. After that, it's a two-step equation, right? I'm going to move that 8 on over by subtracting it from both sides. I'm going to get that 3x is equal to 100. I'm going to divide both sides by 3. And x is going to be 33 and a third, or 33.3 repeating if you want to do it that way. Right? Either way is fine. All right, so hopefully these fraction ones don't seem quite as bad as they might look at first, right? Our very first step is to get rid of the fractions, and oh my god, look at this one. Ugh. All right, so this one looks worse than it is. If you look at the denominators, we only have 2 different denominators, 3 and 5, right? So if you wanted to do the little table off to the side out, on this one, I'm not going to lie to you. 3 times 5 will give you 15, and that'll work just fine for what we've got. So my common denominator is 15. Oops. Somehow I changed colors between one and the other. So we're going to pop a 15 on the outside, and we're going to go through this one piece at a time. I'm actually going to color code it a little bit so it's a little bit easier to see what's going on. Okay. So, again, for these fractions, 15 divided by the bottom, 15 divided by 3 is going to leave us with 5. Take that 5, multiply the top, which is 2. That's going to give you 10 there. All right, so we're going to get 10x. All right, after that, we've got 15 divided by 5, which leaves us with 3. 3 times that 4 on the top gives us 12. All right. Then we're on to the blue on the other side. All right, we've got 15 divided by the bottom, which is 3. All right, 15 divided by 3 leaves us with 5. That 5 is then going to get multiplied by 8. So 5 times 8 is going to give us 40 over there, with an x along for the ride. Last but not least, way on over there, 15 divided by the 5 on the bottom is going to leave us with 3. Oops, 3. And then that 3 is going to multiply the 7 up top to give us 21. All right. So there was a subtraction sign there. I'm going to keep it, so minus 21. After that, we got to get all our x's to one side, right? I'm going to move these 10 x's over. All right, so again, turns into one of the problems we were doing a little bit earlier, which didn't seem quite as bad before we added fractions to them. All right, so we'll get 30x minus 21 over on the right-hand side. After that, I'm going to add 21 to move that away from where my variables are. All right, so 12 plus 21 is going to give me 33. We're going to get 30x still on the other side. And when I divide everything by 30, to get rid of that coefficient, what we're going to find is that 1.1 is equal to x. All right. So I'm going to be honest with you guys. I know that these are pretty long problems, right? We had like 1, 2, 3, 4, 5, like 5-ish different steps, not counting finding the common denominator. They are long problems. It really pays off to organize your work and try to keep everything organized, right? What I would suggest is, especially when we're dealing with fractions, don't try and do multiple steps at once until you feel like you're real good at them, right? It's okay to take a little bit longer on these problems. This last one, oh man, 4/3 x, 7/12, 5/6 x, and 9/4. We have 4 different denominators here, right? So this is where the method that I like really comes in handy, right? If you wanted to, You know, we have a 3, we got a 12, we got a 6, and we got a 4. If I make myself a little table with all of these, and we make that not look like 16, right? 3, 6, 9, 12, 15, and so on. 12, 24, 36, and oh my god, those numbers are already big, so we can stop there probably. 6, 12, 18, and so on. 4, 8, 12, 16, 20. All right, so as I keep going through those, what we're doing is we're looking for the smallest number they have in common. What I'm seeing is that it's just 12. Right? 12 is a common multiple of all of these. All right, so I'm going to use 12 as my common denominator. Big parentheses, 12 on the outside. All right, so what we're going to do from here, same old deal. We're going to distribute that 12 all throughout. All right, and again, color code a little bit so we can talk a little bit more easily. All right, so over in the red, right, we're going to take this 12. We're going to divide it by the 3 on the bottom. So 12 divided by 3 is 4. And take that 4, multiply it by the 4 up top, which will give us 16. And you got 16x there. All right, up next, 12. Divide it by the 12 that's on the bottom there. 12 divided by 12 is just 1. We're going to take that 1 and multiply it by the 7 up top. 1 times 7 is 7. All right. Over to the other side in the blue. All right, we've got 12 divided by 6 is going to leave us with 2. So when we take that 2, we're then going to multiply it by the 5 up top to get 10. Oh, sorry. My cat Toby is rifling through some recyclables. So we're going to get 10 left over there, 10x. All right. After that, we've got 12. We're going to divide it by that 4 that's way over there. 12 divided by 4 gives us 3. We're going to take that 3 and multiply it by the 9 on top. That's going to give us 27. Okay. We're almost there. Oh my gosh, this problem looks so much better now. I'm going to move all my x's to one place. I'm going to move those 10 x's over to be on the left. All right, so I get 6x plus 7 equals 27. I then have to move that 7 over away from where the x's are. I'm going to subtract it from both sides. We're going to get that 6x is equal to 20. And then last but not least, we got to divide both sides by 6. And x is going to come out to be 3.3 with a little repeating on it. All right, it's 3 1/3. All right. So I know that this was a pretty long one. What I would say is, don't worry about the practice problems at home. We're going to practice them when I see you next time during class. If you have questions, you can email or definitely ask them when I see you in person. Right? And I'm going to stop talking so you guys can get out of here. See you next time.